I kind of have four main topics that I plan to talk about today. General planning and design process that we go through when we develop revegetation plans, some examples of strategies and techniques that we use commonly when we're developing our revegetation plans. We'll talk about plant materials and species that we tend to use, talk about risk management during the establishment phase after we've done our planting. Often it's required or necessary to make these projects be successful. And then I'll touch briefly on monitoring and how that can inform maintenance and adaptive management decisions when we do our revegetation projects. So as we're developing our revegetation plans, one of the first things we do is go out and do a site assessment and see what it is that we are looking at a site. And then we proceed on to revegetation design. After that, I'll go over more topics within these on my next slides, but those are kind of the key bullets for how I'm organizing this planning process. Site assessment. What are we looking for when we go out there on a site when we're tasked with coming up with a revegetation plan? First, we want to know what's there to begin with, what kind of vegetation communities are present, the species that are there, what kind of soils are available on site, what the existing hydrology is, whether there's a stream, existing wetlands there, features that we may want to preserve and protect, other sites that maybe are less desirable and not quite the vegetation communities that we're after. We look for reference conditions too that may inform how we might design desired plant communities, if there's certain soil types that we're looking for or hydrologic conditions that we want to emulate throughout a larger part of the project area where we see successful vegetation. Sometimes reference conditions aren't available on site. We need to look elsewhere for them or go to literature and different places where that may be described better. We also look at limiting factors. We call what we typically think of as limiting factors or conditions that may be limiting the site potential to achieve our desired vegetation community. It may be like an incised channel where we have a floodplain that's no longer connected. It may be a land use thing where there's grazing present in a riparian area, and so we don't have the desired species that we're looking for. So what does that look like when we define our existing communities? This is the Milltown Dam site where the dam was removed and the floodplain was rebuilt. And so before that project happened, we were part of a larger design team that went out and we did vegetation mapping in the part of the dam and reservoir that wasn't the reservoir. So upstream from the reservoir, mapped those vegetation communities. We came up with 26 different vegetation types out there for the most part. And some of those were desired vegetation communities like existing cottonwood stands, wetland swales. Others were more a disturbance community like riparian pasture and things like that out there. So then how do we determine if it's a reference community or if it's a disturbance community? And this is where we then go to the literature again for some of this. I picked a couple classification and vegetation community descriptions. Hansen, the riparian classification of Western Montana's riparian and wetland sites. He's got a lot of great, they went out and did vegetation surveys at a bunch of different sites to come up with this classification. So he's got a lot of great information in there that's useful to kind of understand process, timeline, and development of these plant communities. He's got habitat types and community types, which are kind of based on climax community as a habitat type and cereal communities that may still be in development or community types. I put in the example of a black cottonwood, red or dogwood community type. That is one that we often see in riparian areas where we have a well-developed forest layer with a nice shrub layer in there that has native species in it, and often it'll have herbaceous native species. And so that's more of like a reference condition that we would use for designing wetlands and riparian areas versus the black cottonwood herbaceous community types, where that may be more of a disturbance community because there's something that happened where your shrub layer is missing in that community. And so that's kind of what we're looking for when we relate that back to our limiting factors of why is that shrub layer missing and what could be done to try to get that back. Let's see. Oh, I wanted to mention the ecological systems from the Heritage Program. Those are also really great references. They're very detailed. All of these have nice species lists in them that you can use for reference. Not always can you use a reference species list to develop a revegetation plan. Sometimes these species are not available or practical to plant or seed, but it is good for reference to understand what kind of plants you would expect to see in these various communities. So these are just some photos of the limiting factors and some site conditions that we get into before we do a project. Stream bank erosion with no woody vegetation along the banks to hold that in place. That's pretty common. That's what a lot of revegetation projects are doing. It's to address stream habitat conditions and floodplain habitat. We see floodplains with the grassland there, where normally you would expect to see shrubs and a lot more height diversity within that community, but whether it be just logging or grazing or whatever disturbances caused that shrub layer to be gone, and the trees in this case. So as we start thinking through how we're going to develop a revegetation plan, these are just some best practices that we like to keep in mind. These are wetland riparian areas. They often involve water and require water for these plants to be successful. So we want to make sure that we're designing these areas to be connected to the hydrology that's available. We want there to be overbank flows, groundwater support, and keep the roots in contact with the water table for at least part of the growing season. We also want to make sure that we are thinking about how we're going to protect these newly establishing plants against browse. There's wildlife. We're often doing these projects for wildlife habitat benefits. And so we eventually want the plants to be available to the wildlife, but as they're establishing, we can really wreak havoc on eating little plants, and that can sometimes cause a risk to survival and success of a restoration project. And we also want to make sure we're creating appropriate spaces for these plants to get going, whether it be via natural processes and natural recruitment, or for our plants that we're putting in the ground. And this will get into some of the maintenance with climate the way that it is, and we have some dry summers. We've had some dry summers where we've gone long periods of time without any rain. And so sometimes we do need to water as we're getting plants through that establishment period. They're planted and experiencing some drought stress. And patience. Plants don't grow overnight. Wish they did, but they don't. So exercising patience in this whole process and being adaptable is really important. So this is kind of an example of how we think about revegetation design and layout within a cross section of a valley. So this is it's kind of hard to see. In the center here, like a little bit, that's kind of the main thread of a stream channel as an example. Along depositional, this is a meandering channel type of an example. So it's not like a steep mountain stream. This is, just one example. So this would be, this is for the Milltown Dam site on the Clark Fork River. So we have a widely meandering channel. It's got side channels that are seasonally connected. And so you have different vegetation communities along that gradient. And this isn't necessarily the design that we would put out there to be like, we're going to plant this and this is what it's going to look like. But this would be the goal that we would like to see as a long-term outcome for that. So we want to set the stage for getting to these communities and have the right kind of substrates in place. I apologize that you can't really see very well what these words are, but along the channel, it says imported alluvium for the channel bed. So you want to have the right kind of gravel in the stream, sand and gravels and cobbles up on that next floodplain terrace, which would be the depositional feature where overbank flows access that. And then as we get further out into the floodplain, we start to develop finer textured soils where we'll have silt loams or sandy loams, and the vegetation communities also follow that soil gradient, elevation gradient as we get further and further out of the floodplain, and eventually transition into a riparian or upland corridor along the edge of the river system. So another way to illustrate this is we call it a plan view form, bird's eye view of how we would lay out this. This is really a conceptual layout. And again, I apologize, you can't see what these words say, but the colors represent different vegetation cover types that are kind of the goal for what we would want to see at this site long-term. And it's the same thing that was illustrated in cross-section where we have our riparian communities as dark purple along the outer edges. We come into more of a mature cottonwood community in the lighter purples. And the green is kind of that younger age class of cottonwoods and willows that you see closer to the channel, where those are more newly established species. And then there's some low spots in there. Oftentimes in wetlands, or in riparian systems, the channel moves around and we have abandoned oxbows. And so we'll have those depression features that can support wetlands, maybe even herbaceous wetlands and shrub dominated wetlands. So those would be like old oxbow features or just scours in the floodplain. And then as we get closer to developing an actual revegetation plan, this kind of shows examples of how we would use different techniques and strategies. Again, I apologize for the very small text. But what this green polygon here is one of those emergent wetlands. We might use a different planting technique in that area, like using herbaceous plugs in that area versus some of these other floodplain areas like the green, where we would want to plant like container shrubs. And so we'd use different strategies throughout these different types of cover types in the floodplain, and develop different species mixes for them too, because there'll be different species that are appropriate given how wet or how dry these sites may be. Let's see. So these are some of the main strategies that we use for revegetation. We'll go over in each of them in a bit more detail, but I won't read them off to you, but preservation, well, a little bit. Preservation, salvage, and transplant are very important, but we'll go over that too. Really creating conditions that support natural processes is a big thing that we like to try to do. We're often working in really large areas, 10 acres, 10 plus acres sites or more. And so really it's expensive if you wanted to plant an area that large, and becomes cost prohibitive to get that many plants and get them out on the ground and to take care of them. And then we'll talk about planting and seeding as other techniques. But preservation and is really important, I think. Trees take a long time to grow. And if we have them in a site and they're at a good they're at a good place where we can keep them because they're connected to the hydrology and they're already providing the habitat benefits that we're after, we want to try to preserve those as much as possible and take advantage of them being there and not have to regrow them because we cut them down. So preservation is really important. You can transplant some plant material. Really big trees generally don't transplant super well, but a lot of shrubs you can transplant, especially if you have a site where you can just pluck them and put them back in the ground. Wetland sod can be transplanted. Another time when you would want to consider preservation is if you have really unique plant communities or sensitive species. Those would be good opportunities to say this is functioning well, obviously, because we have these species here, so we would preserve that. And so we often flag those off and tell people don't go in there and keep these protected. So those are examples of when we want to keep things the way they are and preserve that. And this is one of my favorite processes in wetlands, well, in riparian areas, is the cottonwood recruitment box theory that John Mahoney and Stuart Rood have published about. They've done a lot of research on rivers in the West and throughout the West, and sometimes in regulated systems too, where they're looking at how stream flows impact cottonwood recruitment. And so it's also based a lot on the life history and ecology of cottonwoods. I have another reference for a paper that they also cite in their paper for that, because the two are very interrelated with the life history of cottonwoods and hydrology. So what is this? This cottonwood box is all driven on hydrology, and I think it's pretty cool. What it is when we have a spring flood, and as that flood flow recedes, it tends to coincide with the seed release timing of cottonwoods, kind of mid to early June to the end of July. And as that water recedes from the flood, the cottonwood seedlings can land on those moist surfaces and germinate, and they can grow their roots about 1 inch per day is what they've found in the study. And so if the water recedes at that rate of about 1 inch per day, then you can get cottonwood recruitment. And there's several things that also relies on besides just this hydrologic connectivity. You also need to have a surface that's appropriate for those cottonwood seedlings. If it's all grass, it can't really get established in there. They like to have those new deposition like sand deposits or scour deposits where you've got bare soil that they can just land on and start going. So this is what that looks like for a hydrograph. The lines are flows, CFS flow, cubic feet per second of flows throughout a year. And the big peak in the center is the spring freshet where we have flooding. The box in the middle, the left and the right bands, are the cottonwood seed release timing during the year. So we have this, and then the diagonal line is that approximately 1 inch per day of decline in the water table. And then the green band is the zone that would be appropriate for cottonwood recruitment as far as their longer term survival, because sometimes if they get established up really high, that surface may be too droughty for them to really truly get established on. Or if they're too low, they may be inundated for too long during other parts of the season and drown. So we they kind of like that sweet spot, and it can range. But one thing that's really important is that these are infrequent events. They don't happen every year. As you can see, there's several of these lines where they don't quite hit the timeline or the elevation for when those seeds are released. But the cool thing about cottonwoods is that they release a ton of seed. They're end producers. So they're trying to take advantage of those years when they get a good flow, and you can have a forest. And so this is one of the strategies that we really like with revegetation, is let nature do its work. Set the stage and hope that you can get a year where you get a good flow. So that's one of our main strategies in these riparian areas, is to really try to take advantage of that natural process. So as we're designing these floodplain surfaces, what we like to do is incorporate a lot of topographic diversity and elevation range within the bounds of where we think these vegetation communities can be supported. So we know kind of how high up the water gets when it floods. We know how long it's there for in a lot of these systems. And so we can kind of have our upper and lower bounds of these elevation ranges. And then within them, we make them really messy and make a bunch of different microsites where the water can pool, it can collect seed, it can collect leaf litter and carbon and all these other inputs that flow through the water system. And we incorporate brush and logs that are partially buried in there too. So those also create like little micro shady sites. It's not a ton of shade, but it's more than just a flat barren surface where everything's just going to slide right off. So we're really going for as much nest and diversity as you can see. Sometimes when we have equipment operators out there, they like to grade things nice and flat, and you're like, okay, that's great, now mess it up. But it's really cool. This picture up in the top corner, you can kind of see that there's green spots, and a lot of those are in those little micro depressions. And so it's kind of creating those little sites where you get a little more seed collection and opportunities for them to get established. So once we kind of set the stage in the floodplain, then we move on to planting. And there's many different strategies you can use for planting, different plant materials. This is just one example of like a large floodplain area where we did kind of dispersed planting throughout. And this is kind of a regular spacing, probably 8 to 12 feet on center spacing. And you just spread plants throughout because you want to cover a large area, and you may not have them as dense as you would see them under natural situations, like all those little baby cottonwoods all crammed together. But this does get you hopefully a canopy of woody vegetation as those get established and start to create shade in that riparian area. Just a note that this floodplain area is also seeded so that we're not leaving too many open spaces for weed colonization. We do also like to be strategic about where we seed. When we're expecting a lot of cottonwood recruitment, we may not seed like those lowest floodplain elevations to allow there to be space for those cottonwood seedlings to come in and take advantage of that. So we also look at what's going on in our sites. This top picture is just a natural condition where there's a whole bunch of woody debris racked up in the trees. And often when you see that, you see a bunch of other little plants growing up through that woody matrix. And so we've kind of tried to mimic that in some of our plantings. And this illustration on the corner is what we call a cluster planting. And what we do is we take brush that's just cut from trees, like limbs and branches, and plant those in the ground, which is what these are. They're not actual plants that are planted. It's just conifer branches that still have needles on them. But we spread them out in these wide bundles to kind of create this messy matrix of wood that is like when a tree branch falls down and you have all those limbs that stick out and you can't walk through it. So we try to emulate that with making these protected sites in these riparian areas so that natural recruitment can happen in there, and we can also hide plants in there and keep them protected from browse or other disturbance. Stream bank vegetation is really important. The pictures here illustrate bioengineering techniques, and this is a pre-vegetated coir bank, vegetated soil lift that uses coir wrapped soil layers with willow cuttings stuck in the middle between the layers. And it's usually a very successful technique. This is one that has all the willows growing along the Fork River. Looks really great. There are times when these don't work. This is one where there's an enormous amount of browse, and the beavers came in and ate every single willow cutting in the bioengineering structure. And every time they would try to grow out just a little bit more, they would come and eat them again. And so there's times when you need a little something more. And so we've worked with some engineers on these projects and come up with some other alternatives. This is what we call a brush bank structure. And what it does is, instead of using coir, we use a lot of brush, really dense brush in that bank. And then these green things in here are little cottonwood bundles that we put in amongst that brush so that we can get some woody, or we get those cuttings to grow in and amongst that woody brush matrix so that we can get good stream bank vegetation that'll provide that longer term root mass to hold the bank in place and help resist erosion. This is a little hard to see, but this is one of these brush bank structures that is just chock full of willows. They're like 10 feet tall. It's one of my favorites. So when we think about what kind of plants we want to put in our plantings, we primarily only really plant native plants. We want to get the species that are supposed to be in these riparian areas. So we want to get ones that are from this geographic area, that are at the right elevation for the species that we're targeting. We look at things like the C value. Some of these are very tolerant of disturbance. Like I think the C values of 0 are like noxious weeds, and then 5s are some of the more native plants that are not very tolerant of disturbance and may not actually be ones that we would want to plant because they may be harder to get established as far as planting goes. Not that we don't want them, but They just may be harder to plant and have success with. We want to think about what the risks of planting a plant are. If it's a really highly palatable species, it may require a lot more effort to get that species going. It may require extra protection to really keep it going. It's like when you plant tulips in your yard and the moose or the deer come by and eat them, you need to fence them. You can't just leave them out there. Should pick a native plant instead of tulips, but they like them. Availability of the plant material is really important. Not all plant species are available to buy as plants, and so we kind of have to deal with what's available. Sometimes there's crop failures and species just don't come out, and so we're often working under those situations too of what's available and appropriate. We also think about successional status. We would love to have like cedar forests. Sometimes those are not, that's a later successional plant community where you can't necessarily just have a cedar forest. It's something you could integrate in. You can certainly plant cedar, but they prefer a shadier environment. And so it's just one that maybe isn't your first go-to as you're starting out on a new site. It could be a later effort if you want to try to get some of those species in. So this is more just timing for when we do tend to plant. We like to put plants in when they're dormant to try to reduce the stress on them. I'm sure a lot of you are familiar with good times to transplant and not. And so fall tends to be a good time. Spring can be a fine time to plant as well, but sometimes we're working in these wet areas and flooding happens before we're ready to go or as you're getting ready to go, and then you can no longer access your site. So fall tends to be a good time to plant. We want to seed as soon as we can too, just to prevent unnecessary weed invasion in a site. We're often creating a disturbance, and it's a design disturbance, but nonetheless it's a disturbance, and noxious weeds sure like it when we make disturbances for them to jump in and take over. So we want to get the right plants in there as best we can. Herbaceous planting, tend to do that in the summer after runoff while the ground is still wet, and give the plants a chance to get their roots going before they go dormant again for the year, so they have an opportunity for early establishment. So this is where I talk about a few plants, and I apologize. There are so many plants that we could talk about for revegetation, and I picked just a few favorites, and I'm sure everybody else maybe has others, but I just picked a few that are pretty commonly used and also just ones that suited my likes. Cottonwoods are one of my favorites, obviously. They perennial deciduous tree. They're facultative wetland, which means they're likely to occur in wetlands or drier sites. It's a rating that's used in wetland delineation, but it's one that we often use when we're looking at what kind of hydrologic tolerance a plant has, so we can decide where to put it within our elevation range in our sites. It's generally relatively available commercially. You can buy it in many different forms: bare root, container plants, whips. We don't often use it as a whip, but I think it can be, especially if you put it with cottonwoods. And they are a great deep-rooted plant that's going to help provide stability in a floodplain. We do expect floodplains to change over time and erode and migrate. And if you have these woody plants in there that have really great roots established, they're more tolerant of that. And even if they do fall down, you've got this great extra woody debris material that's present in your floodplain. So they're really great for providing that diversity. And willows, we all love them. Willows are super abundant, and there are so many different species of willows that can be used for revegetation. Drummond willow is often one in the floodplain. We see sandbar willow along stream banks. We see it on ditches. It's readily available for collecting for cuttings. Gyre and yellow willow will often be in floodplains too. Bed willow is kind of nice because it seems to be a little more tolerant of grazing and browse. So we see it a lot longer in those kinds of situations. Again, you can find these as container grown plants, and They also grow well from cuttings. We include them in our bioengineering structures and various treatments where we want to just stick them in the ground and have them grow. We did do a project where we had custom collected cuttings grown up into plants. So we had site adapted plant material that was grown from these local cuttings, and that worked out really great to get a lot of plants from those. And it's real important to practice best practices when you're harvesting cuttings. It's can easily over harvest a site. Sometimes if you're harvesting along a ditch bank, people don't really care if you take them all because they would cut them down anyway. But in natural areas, we don't want to take too many of them. We want to preserve the stand that we're taking from and be mindful of whether there's already been a lot of browse from beaver or deer on those. So we want to practice best practices for harvesting with those. And you may need permits depending on where you're harvesting. I really like alder. We see a lot of that come in well when we plant it. It does well in these early successional communities. It's a nitrogen fixer, which is also pretty good to have in your floodplain early on. Pretty readily available commercially. We also see it come in via seed, and it probably comes in with some of the flood flows. And but we'll see little seedlings in our floodplain sometime of alders too, in addition to the cottonwoods and willows. Red osier dogwood is just a great plant. It is highly palatable. The deer like it. It's kind of an ice cream plant is what I've heard people call it. And, but it is a really good structure, good for wildlife. And you can use it from vegetative cuttings. We'll mix it in with our willows when we use them in stream bank treatments, and they do pretty well. Also, yeah, container plants. I think you can probably get them bare root. I know that there's some plant people in here. They can probably correct me on what type of materials are available. Woods rose and some of the ribes, those ones that have thorns on them, are also kind of good to keep to have in your mix. The thorns can help provide a little bit of natural browse deterrent, so that we don't necessarily have to take so many protective measures to get those established. Also, the berries are great fruit for the birds and any other wildlife that would get to eat those. And as I said, there is a huge long list of plants that we could talk about all day for what we could plant. This is just a quick list of some other ones. We do try to include conifers, especially at that edge of the interface between the riparian and upland areas. We'll put in aspen that are slightly drier. Snowberry, and snowberry seems to do pretty well and spread once it gets in there. Chokecherry is another good one, especially for food sources for the wildlife. Raspberry, a little more shade tolerant, but and then herbaceous planting. We include herbaceous planting, but very strategically, because it can be very expensive. The plant material is because they're smaller, and it just takes a lot longer to. Oh, that species is just terribly small. Sorry. And these are just examples of species, but you can get them as herbaceous plugs, sod mats, pre-vegetated coir. There's a whole bunch of different options for herbaceous material that you can plant. There's a bunch of the species that are listed here. There's Arctic rush, all fruit sedge, beaked sedge, blister sedge, common spike rush, hard stem bulrush, knotted rush, meadow bulrush, Nebraska sedge, panicle bulrush, Torrey's rush, and water sedge, and woolly sedge. And those are just examples. A lot of times you can request species if you're doing herbaceous planting, if you have enough lead time to where they may be able to provide a certain species for you if you're looking for something specific. And then seeding is kind of our last step after planting. Well, almost last step, but we develop usually at least a couple seed mixes for our project areas, depending on the elevation gradient and where they're occurring. In our floodplain areas, we may have a wetland mix that goes down along the low bank or in any of the off-channel areas where we include some sedges and rushes in those, along with some grasses and forbs. Along the floodplain, when it gets a little higher up, we tend to exclude the sedges and rushes because they can be kind of expensive when you're seeding a really large area. Sometimes you may still want to include a couple just to capture we try to include a mix of slightly wetter and slightly drier species so that we're not excluding anything and missing a niche with the seeds that we're putting out there, because you do want to try to capture the diversity of conditions that we're creating out there. Commercially available seed is typically what we get, and species availability can be variable at times. I think last year wasn't great for a lot of seeds, but it can be kind of a limiting factor on how diverse you can get with your seed mix. You can do custom seed collection and use that for either plant propagation or direct sowing. But again, it's a labor intensive effort and to collect it and clean it and get it ready to seed, but definitely something that is doable and possible if you're looking to increase diversity. We tend to dry broadcast seed and then put hydromulch over the top, especially on slope settings. And within our access roads and staging areas, these are big construction sites where they'll be staged up in an upland and have ways that they drive in and stuff. And we reclaim all of those areas, and we'll use more of a simplified grass mix and drill seed that, just so that we're, again, avoiding the potential for noxious weed invasion in those areas. And I apologize, but this is recorded, right? So there's some example species mixes for a floodplain mix, a wetland mix, and then a reclamation mix. We do like to include some of the pretty flowers. The Gaillardia is always very nice to see out in a floodplain, especially mixed with some yarrow, and flax is another one that we often include. But some of the common grasses that we use are blue joint reed grass, tufted hairgrass, streambank wheatgrass. We'll include some Arctic rush. Tends to be a really good one for kind of the wider variation of hydrology. Some of the wetland species that we would include would be like a water sedge or a bed sedge, like the woolly sedge too. That one seems to come in pretty well. Mountain brome is also a good grass that I see established pretty well. There's other strategies that you can use that may just be very site specific. For example, at the Milltown Dam project site, when they were digging out some of those sediments that accumulated behind the dam, they unearthed a historic floodplain surface out there, and it had the old stumps that had been there when they cut them down and first created the reservoir. And when this site was, during construction, it was isolated from the river, so it didn't get river flooding, but there were seeds that grew in there that probably were from a seed bank, even though it was 100 years old. So in floodplains, when you have those depositional environments, you may be able to unearth a layer that, like if you're stripping off reed canary grass sod, for example, there may be a buried seed bank in there that you could get some desired species from. So there may be just unique examples where you can get some other opportunities for ways to get desired vegetation on the site. So after we've planted it, then what do we do to try to help this planting effort that we've done be successful? There's several things that we have to think about and manage for. Trampling, grazing, browse, competition, drought. So talk about those. Sometimes these sites are along rivers and people can float the rivers. Sometimes they like to get out and walk around and check it out. And sometimes that's a lot of walking around and trampling over these new little seedlings that are trying to get started. And so in some projects, they'll close the river, we'll close the floodplain so that people know to stay off of it and be careful, because it's a sensitive, reestablishing environment. Fences are not always great, but they're actually pretty good deterrents for keeping people out and animals out. We often will build fences because a lot of times browse is just really an issue. We'll talk about wildlife in a second, but fence design is really important too, because you can't necessarily fence a really large area and block off access. We found that leaving gaps in fences is really helpful to allow the wildlife to get through in key areas. It's also great for people. When you give them a place to get through, they're not going to necessarily try to bust through your fence to get to the other side. So having smaller fence units has been really a good strategy for these sites. You might have a path that's pretty worn down in the middle, but outside of that, you can end up with a lot of really good revegetation on the sides of that. Grazing, sometimes our riparian areas are right next to a pasture, and we don't really want cows in there right away. So this picture is an integrated livestock and wildlife fence. It has barbed wire along the bottom of the fence and then wildlife netting over the top of it. So that if you get to where your vegetation is established, you can take down that wildlife netting and cut off the tops of the posts, and then you still have a livestock fence there to keep the livestock out. We've also done tall fences with graduated wire fence that really does well for keeping a lot of things out while you're trying to get through that establishment phase. Talk about browse a lot because it's a thing that I've battled with a ton. Wildlife, I mean, a lot of these, like I said before, these projects are intended to benefit wildlife, and we're ultimately creating wildlife habitat, but we just need to get the plants there so that we have that habitat. And so managing browse can be very challenging. We've had all sorts of critters eat plants, the deer, obviously, elk, moose. We've had voles can be a problem in grasslands, where they've been established already in a crop field. They'll girdle the bottom of the plants, and so we've sometimes had to use vole protectors around the base of the plant to keep them from girdling them. Had turkeys eat conifers. Pretty sure it was turkeys. Who knew? Yeah. Yeah, I mean, sometimes it's just things you don't even expect. You're like, how do we manage turkeys? Anyway. This is just some examples of what that can look like. Even with best efforts, sometimes you put up a browse protector cage and they will just eat your plants right to the tippy top. And how do they go from there? Waterfowl, when you do herbaceous plugs, can be vicious. They can just tear them up out of the ground and wreak havoc. Beavers are great, love beavers, but they also will often chew down our trees before we're quite ready for it. And so we come up with different strategies. One of the reasons why we use wire fence sometimes is because of the beavers. They'll chew through that wildlife netting fence and get into what you've wanted to protect, and it's just not durable enough. For herbaceous plugs, we use this suspended twine type of a intervention to keep them from getting in there. It's just basically crisscrossing twine strands that they won't land in because they don't have enough room to land or to take off. And as they're walking around, it pokes them, they'll bump into it, and so they won't go into it. So it provides a temporary measure of browse protection for those herbaceous plugs. While fences are great, they're not always appropriate in a floodplain environment. When you have debris floating down a channel, it can tear apart your fence, and you can see how important that fence can be, where you have inside a fence fantastic vegetation establishment, but nothing outside of it. So this kind of gets back to that cluster planting measure that I pointed out in the beginning. We use this a lot for browse, where we really try to make these dense clusters. And part of the reason why they're also so tight is then there's a path around them. So the wildlife may nibble around the edges. Sometimes we get one that goes in and will eat things in the center of them too. But if they have a clear path around, other things to eat out there, but you can still protect some plants in the center of them, it tends to work okay for helping to protect those plants. It's not as effective as a fence, but when you can't really put up a fence and you don't want to have metal in the floodplain that might get knocked into the river, it's another alternative. Competition. Reed canary grass is terrible. We all know about that. And it can be very difficult, but even sometimes our seeded grasses, sometimes they do really great, like in in a next to a crop field or something where there may be really fertile soils or something. We've had sometimes where our grasses are maybe seeded a little too heavily and have shaded out our plants. And so, and then noxious weeds, like I said, sometimes we've created a disturbance and they may still be in the seed bank and we end up with a great big flush of noxious weeds. So we have to manage those to ensure the success of our plantings. Before we'll use these weed mats at the base of the plants to help with grass competition. This example here was not a floodplain grading type project. It was more trying to get shrubs established in an existing floodplain. And so the weed mat was laid out in big strips to solarize the grasses that were there, and then plants were installed through it so that they could have a more protected, less competitive environment to try to get going in. This top corner picture is integrated weed management. I think that was a big tansy patch. And so it was a mowing effort to get it knocked down and then follow up with selective herbicide application to knock that down and just try to shift the community to less tansy. Flood, drought, scour, and sediment deposition are all risks in these floodplain environments, but they're also natural processes. So we don't want to not have those things happen, but we want to plan for them accordingly as best we can. So we make these diverse surfaces so that there's places for the water to go and appropriate places where we would like to have it be deposited. Doesn't always work out that way, but we do want these to be connected floodplains that do have the ability to change over time. We're not trying to design for something that's going to be static and the same for forever. This is just an example of drought. And like I said before, sometimes we do want to water our plants to get them going because they might need that leg up, especially when we have our super dry summers, but can be very important. So most projects will include a monitoring component. Not all of them necessarily do. It's always good when they do, but it can inform your maintenance and adaptive management process because you do want to go out and see if you're achieving your goals. Are we meeting survival criteria that we've set forth before a project? Are we achieving the desired canopy measures that we wanted and cover type community, vegetation community types that we're hoping to get? How's our noxious weed level? Is it high or is it okay? And then that helps inform whether or not we might need to go in and do some corrective measures like weed control, additional planting, just some extra browse protection measures. And one of the most important monitoring things that we collect, I think, are photos. We go out and establish permanent photo points, and those really tell a good story of what is happening in your site over time. And you can really see changes in vegetation communities and diversity over time. So, oh, I already kind of went over this, sorry. These are examples of measures that you may see out there, what you might do to correct them, of replanting if you have really poor survival. We've had some sites where they flooded in large parts of the plant, just an abnormal year, one of those like 100-year events, and the plants just drown out. You might need to replant a little bit to account for that. This is one of those questions that we get asked a lot. How long is it going to take for the plants to establish? When can you take down the fences? How long is it going to take? And we do have measures from projects where you have longer term monitoring data sets. And so we generally set criteria for like short term of like 0 to 5, 0 to 10 years, and then longer term of like 15 plus years. But it's variable and it depends on a lot of different situations, circumstances within your site. And if you've designed, if you're able to integrate those best practices, it does help with improving chances for success. So there we go. I'd like to acknowledge my coworkers, Tom Parker and Amy Sacre. They helped with some of the content for this, and they've been great to work with for the last almost 20 years now, and great colleagues to have. We do work with the Kootenai Tribe of Idaho for a project that's funded by Bonneville Power. We've done a lot of work for the state of Montana, the Natural Resource Damage Program, the Milltown Project, and others. And so some of these examples are from them, as well as some from the Confederated Salish and Kootenai tribes. And that's what I got.
Anyone have questions?
Yes, Pete.
So when you were talking about cottonwoods, it said that it gave me the impression that you planted them or that you used cuttings for black cottonwood.
Rarely do I use cuttings.
Okay,
Rarely. Occasionally they'll get in with the willows.
okay, because I've never heard of that one before.
Yeah, we don't usually use them.
Okay.
No, I mean, we do plant them as container grown plants, rooted material, and then try to set the stage for the seeds to help. But yeah, occasionally they get in with the willows, but rarely.
And the other thing is, when your seed source, do you use local seed, or are you getting this from Nebraska or Colorado, or
For the plant material or seed or both?
for the seed?
For the seed, try to at least get it regionally.
Okay.
Yeah.
And regionally includes.
Well, commercial seed is a little more difficult.
Right.
Yeah. I won't lie. Some of it may come from other places, but we try to get the varieties that, it's a native species here. Yeah.
But I mean, so I know some out in eastern Montana, when the Conservation Reserve Program, and so this rancher planted, and he planted a native stuff, but the seed was from Nebraska. And like 2 years later, they had a pretty dry summer and it all died. I mean, the whole 9 yards. Have you ever had an experience like that?
I don't know that we've had complete failure. We've definitely had some times where the seed hasn't done as well as we'd like. Yeah.
And you think that's because of where it came from, or I mean, maybe there's no way of knowing, but
I think there's a lot of variables that can affect that. It could be where it comes from. It could be how it was applied. It could be if it wasn't stored properly. I think there's a lot of variables that could influence that. But yeah, it is hard. I mean, getting seed in quantities where you can seed 10 acres, it's a lot of seed.
yeah,
It's a lot of bags.
Are there local places that collect locally and propagate locally and stuff?
I think there are, yeah. I think there's a place in Arlee that does some local collection, and it's just, I don't know that they have those types of quantities.
Yeah.
Yeah.
Right.
Yeah.
Okay.
Yeah.
It's not profitable to do.
Yeah. Yeah, it's expensive. I mean, we have done that for projects where they've gone out and custom collected specific species that we wanted to include, and often they use that to grow up container plants so that they can be planted, and maybe just a little bit of direct seeding. But yeah, it's a big effort.
When you do a project like the Milltown Dam restoration, so how many acres was that?
A lot. More than 10.
Yeah, that's right.
Yeah, it was a multi-phase project too. And I do have to acknowledge that's a big project. It was a large interdisciplinary team. We were certainly not the only people working on that project. Engineers that we teamed with on that, and the state and everybody. But yeah, they implemented that over many years. Yeah.
And so when you sign up to do a restoration project, how long do you consider yourselves responsible for the success of it? Like, how often would you go back and go, oh geez, these guys died, let's replant? I mean, is that just another contract? Or?
Yeah, and it's very project specific. It depends a lot on funding. Some projects only have funding to monitor for a year or 3 years. With the Milltown project, one of my colleagues still goes out and checks occasionally for things too. So she has had the opportunity to stay involved with that to some degree. But it largely depends on the project and the funding available and what kind of long-term agreements are set up for that. It's great when we can have long-term ones where we can stay involved, because we do like to see how they change over time and like to see if we were successful. It's helpful for us to know. So, yeah. Doesn't always happen, but we like it when it does.
Any other questions?
Well, you know what, actually, except for it's way back at the beginning of your thing where you had some of those drawings that had, okay, this green part,
Mhm.
but you had pink parts. That were
Yeah.
parts that were pink, and I was thinking, what are the rest of the colors in there?
Yeah.
And are they part of your project?
See, we can go back to that.
Yeah, it's like.
That's okay.
This
This one.
Yeah, that one.
That one. All right. Good
So you had
question.
the green, the light green.
Yeah. So the light green, let's see. This is very tiny. The dark purple is riparian conifer. So that's kind of a mature conifer that you would see at the outside edges of the floodplain. The light pink is mature cottonwood. So it's kind of the earlier cereal stage of that, where you maybe might have some conifers that are starting to encroach in your floodplain, but it's just those mature, mostly the mature cottonwoods. I'm having a hard time reading this. Oh, the purple, the medium purple is other shrub. And so that's just kind of along those edges of those maybe old side channels, seasonal side channels. Yeah, willows and alders and just kind of a shrub, more of a shrub community. And then the light green is those younger age classes of cottonwoods and willows. So they would be kind of like the pole cottonwood age class in there. And then pole age class, so not seedling, sapling, pole. Yeah. And then the medium peach color is kind of that colonizing exposed depositional area where you'd expect to see cottonwood seedlings starting to develop.
And so the parts where you would be largely working would be the light green.
Yeah, that's where the planting effort would be focused, because we want to try to get some woody vegetation in there that's starting to mimic those, at least the early cereal vegetation communities. We can't really put in mature trees.
Right.
That's just not a thing we can do. Yeah. Yeah. But then we do try to set the stage for all of those processes, that natural recruitment to happen throughout that zone.
So when you go walking through a riparian area, like say in Missoula down by Tower Street,
Mhm.
do you look at that and go, oh my gosh, or do you look at it and think, oh, this is pretty nice?
I can't say that I've been out on Tower Street.
Oh.
I'm sorry.
Well, how about Council Road? Somewhere along the Clark Court and the Dew.
Yeah.
By the Metcalf.
Yeah. Well, in Hamilton's pretty cool. I just moved there a few years ago, but the river through a large part of Hamilton is open for public access. Yeah, there's a conservation easement on the Scalco Bend property that the city has taken over. The river park is there, Kiwanis Park. You can go along the riverbank, and so there's just full access to that. And within it, there's Scalco Bend has the water forum did a great project there with a setback planting area to kind of get some vegetation established as that channel migrates towards there. I don't really want to talk about too much. I'm not a representative of that project, but it's a cool one to go look at. And then River Park is cool. There's all of these communities are present in River Park in Hamilton, where you see the mature cottonwoods, you see some conifer encroachment in there. The shrubs along some of the old side channels. I could sometimes go through there and take pictures of those as like, this is a good example of these on-channel water features. Yeah,
Okay,
yeah.
thanks.
There is a question on Zoom.
Okay.
Andrew Morgan would like to know, how far is too far to source willow cuttings? Same
Oh, boy.
watershed, 40 miles, upwind, downwind, or upstream, downstream, any of those?
I would say, it depends, which is probably a terrible answer, but it depends.
The real
If you
answer.
have willow cuttings nearby, that would be great. Sometimes willow cuttings and available places where you can harvest are not nearby. And so I think as close as you can get them, try to get them in the same watershed. I know that elevation can be a concern with harvesting from, with as species migrate with climate changes and stuff, that's something to consider, but sometimes we can't be too terribly picky if we need those materials. But I'd say try to stay in the watershed, would be close.
And then Steve Kletzel wanted to just note that supposedly cottonwood and red osier dogwood cuttings can be combined with sandbar willows for rooting.
Yes.
Sandbars and some willow species have an excess of rooting hormone to share.
Yes.
So,
yes. Which
for those who don't know that, it is a cool property.
Yes, it is very much so.
What is it?
Go ahead.
If you,
I can't remember exactly what the hormone is called.
no, I can't either.
But it is what allows the willows, their buds are indeterminate. They can grow as leaves or they can grow as roots. And if you put them in the ground, they'll grow as roots. And so they root really well from cuttings. So if you put buds in the ground, they'll start to grow roots. If you put them with other plants, which is why if we end up with a cottonwood in there, it's not the end of the world when we're doing these cuttings, because the hormone that they release helps others also root. Yeah.
So you can put it in a jar with other things that you want to root and it'll help them. Consistent rooter.
Yeah. Yes.
How many projects do you do in a year?
How many do we do? That also depends.
Sure.
Yeah. Personally, I've been working on I work on a project in Idaho, and we will have like one big effort per year. Sometimes we have like 5, 6 or something. Yeah.
Yeah, I was also curious about, so are your customers primarily government and large business, or do you have private, like ranchers or
Occasionally get private landowners.
people who buy a lot of land and have a lot of money and
Sure.
spend a lot of money on fences? I think.
Yeah, we have a lot of ours are with government and tribes. Is some of our bigger projects, but we do work with private landowners. Sometimes we come in via conservation group, like the Bitterroot Water Forum or the Land Trusts or something like that. Clark Brook Coalition will help landowners. Yeah.
Were you guys involved with that restoration on Burkport? That is south of the east side of here, or
I don't think so.
that was very successful. It
Yeah.
was overrated.
Okay. Yeah, we're certainly not the only people doing this. But and it's good that there's other people that are doing this too. Yeah.
Right, one more question then. Have the CSKT been successful in restoring the wetlands and riparian areas of the Jocko, and have they met their goals?
Well, I don't know if I'm qualified to speak to that entirely.
Whatever you can speak to.
We do work for them, and I would rather that they provide their input, but I think they have been pretty successful. But yeah, I would certainly defer to a CSKT representative to speak on behalf of them.
Okay. Any other questions for Sarah? You can always talk to her more once we have our snack time.
Okay.
All right, thank you.
Thank you.